So as I mentioned this morning, the schedule has changed. I've just got word that that's been updated on GitHub. So if you want to refer to the correct schedule, instead of you looking at the paper in front of you, definitely check out the GitHub repo that is mentioned at the top of your schedule. Then you'll be able to see the official times for everything. So we just had Mike C. Thank you, Mike C. We now have Mike R, and he's going to be talking to us about Azure Compute Infrastructure and containers. So without further ado, please give him a warm welcome.
Thanks, everybody. Can you hear me okay? All right, cool. All right, so I've got a ton of slides, 74 slides, so I'm going to be going through them pretty fast. We are talking about architecting Azure Compute Infrastructure. The bulk of what I'll be talking about this morning are designing virtual machines with Azure Resource Manager, then also talking about how to deploy VMs as part of an ARM template, and I'll be talking a lot about ARM templates. I heard that's there are a lot of questions on designing ARM templates on the exam. I'll be talking about designing for regional availability and high availability with availability sets. They asked me to cover a little bit about containers, but I heard there's a session, over lunch about containers, so I'll just mention that really briefly. And then, like yesterday, the items I haven't read, I feel like are the key points. So I'm going to fly by a lot of this information, but I'll focus on what's in red. Okay? So let's talk about VMs. The way I think about VMs in Azure is that when you choose a VM, you're really buying three things. You're buying a set of cores, a set of RAM, and a temporary disk, right? Even the operating system disk is kind of divorced from the VM itself because that requires its own storage charge. The network interface card that connects your VM to the VNet that it's in or the internet is also separate in ARM. And you can have multiple NIC cards associated with your VM. Pricing for VMs is charged by the hour, and if you're only run for a partial hour, it's actually charged by the minute. By default, you get 20 cores per region per subscription. So you could have, theoretically, 20 VMs with 1 core each. That is the soft limit. Yesterday I talked about soft and hard limits. So 20 is the soft limit, 10,000 cores is a hard limit. And if you need more, you need to move to another region or you need another subscription. So when you think about these hard limits, there's really no hard limits because you could always add more subscriptions, right? Okay, so I'm going to talk about how to design VMs, and what's important when we think about designing VMs is what the workload is, right? Think about what your workload is first, and then we can talk about what kind of VMs we want to create. Before we talk about that, let's just talk about VMs and paths, right? Because VMs are a kind of traditional way we would deploy our application, or with an operating system. But in this chart, which is our shared responsibility model, right? When we're in VMs, we're in infrastructure, and when we think about infrastructure, we have our applications, but we also have to worry about patching the operating system, any kind of application, platform, middleware, the runtime, .NET or the Java runtime. We have to take care of all of those things, right? So that's more overhead. Whereas if we use platform as a service, like web apps, or software as a service, like something like Azure Search, right? We don't have to worry about any of those things. So why would we even deploy with VMs, right? I mean, there are still a lot of reasons why, right? Here are a bunch of the reasons why. So just be aware that VMs are one way to deploy applications. We have other ways in Azure. But obviously, VMs are really popular still way to deploy VMs. Sorry, applications. These are the list of supported operating systems in Azure. So we have a bunch of Linux distributions and Windows. It's important to know that through the Azure Marketplace, you could spin up Windows 2008 R2 plus meaning and anything greater, so 2012, 2016. But there is support for Windows 2003, but not through the Marketplace. So if you have Windows 2003 based workloads and you want to run them in Azure, you have to provide your own VHD for that. I think if you have an MSDN subscription, you can, or at least, there is a way to do that. Yeah, through MSDN, you can create like a virtual desktop, solution. But I don't know if that'll be on the exam or not, right? These are the VM sizes. We have dozens and dozens of different kinds of VM sizes. These are the high-level categories. We have general purpose, compute optimized, memory optimized, and so on. And VM sizes really determine the amount of RAM you get, the number of cores you get, the Azure Compute units, which I'll talk about in a second, the disks that are supported, whether standard disks or premium disks are supported, how many NICs, the network speed of those NICs, how big your temporary storage is. So when you choose a VM, you are kind of getting locked in to whatever capabilities that VM size provides. And if you say, well, I choose a VM that has 4 gigs of RAM, what if I want to upgrade to 8 gigs of RAM? You can't do that. You'll need to completely resize the VM, right? So there's no way to dynamically change these resources attached to the VM. The resources that are attached to the VM itself. Everything else I said that was kind of divorced from the VM, the disks, the network cards, those things you can change. But when you think of a VM, it's cores, RAM, and temporary disk. You can't change those once you're in that size, but you can resize. So this is just an example of the general purpose VM, the set of the general purpose VMs, just to give you an idea. I wouldn't say for the test you have to memorize every single VM size and capability, but just realize which VMs are, what series are associated with this, going back here to which kind of high-level category, right? Which are the memory-intensive series, the G series, right? Which are the storage optimized, the L series, and so on. So disks are a big part of how we configure the VMs. There's 3 kinds of disks in Azure. There's the OS disk, the operating system disk, which you need. And of course, that, like I said, that is charged in addition to your VM. There's a data disk, and you can have multiple data disks. The size of your VM limits how many disks you can attach. And then there's a temporary disk, right? It says attached via SATA or SCSI. Those details are abstracted from you. You attach them the same way through the Azure APIs or the portal. The temporary disk doesn't persist. That's important to know, right? So that you get really nice throughput on that disk because that disk is on the same it's on the host server for that VM, so it's local, but it doesn't persist because your VM can move to another host at any time. That disk can go away. So usually the workload we say for there, the example is if you have an application that's processing images and it needs to have some kind of local swap disk space or something to work with those files, to resize them or something, you can use a temporary disk. And if it goes away, if you've got some kind of queue-centric workload, you can just get that image again, and then you work on it, and then you put it into some kind of permanent storage. So that may come up. What kind of workload would you use the temporary disk for? For anything ephemeral is fine, right? We have yes. Yes, and that's where the page file is actually stored for Windows. Yeah. Oh, sorry. He asked if the temporary disk is a good place for the page file, and I said yes, and by default, that's where it's stored for Windows in Azure. So we have 2 kinds of storage that back these disks, right? We have standard storage and premium storage. Standard storage is hard disk drives, spinning disks, slow. There isn't a latency SLA on those. They're fine for kind of memory intensive, let's say your web servers where your application is running in memory, you don't have to really access the disk. And then there's premium, which uses SSDs, and SSDs do come with some kind of performance SLAs. So the details of which I think it's more important to realize the different capabilities for the exam. Only certain set of series supports standard SSDs or the premium storage. So you see here the DS series, the DSV2, the GS series, the F series, those support SSD, but you don't have to use SSDs with those series. So if you like that series for the memory and the RAM and everything else, that's great. You don't have to use standard storage. Premium storage. All these disks, so when you create disks, you can resize them, and that's in premium or in standard storage. So in premium, you get these 3 tiers, the P10, the P20, and the P30, but that's the initial creation. But actually now, in the portal, you can create disks of any size, and it just maps to the closest tier rounded up. So if I create a 300 gigabyte disk, that's closest to the P20, which is the 512. So I'll get charged for 512, and I'll have the same performance capabilities of a 512. So, so at any time, you can, if you need more space, you can resize your disks. We have, yes? The charge? So there's the question, the charge for backing them up? Oh, that's a good question. Okay, so the question is, in standard storage and premium storage, do we get charged on the provisioned space or the actual used space? In standard storage, you get charged on the used space, but in premium, you get charged on the provisioned. So it's a good distinction. So we have these disks. They are supported with Azure storage backing it, right? Either standard or premium. But we just announced something called managed disks. So before, when you were to create a VM, you needed to create a storage account, and you need to put your disks in the storage account. And it just added a level of complexity to building a VM solution. But now we take that away with a managed disk. You just provision a managed disk, and the platform takes care of the back-end storage for it. So you can choose a standard disk, you can choose a premium disk, you can resize the disks, you can export the disks. You have the same, almost the same flexibility that you have with the standard disks. You don't actually have visibility. You can't go into a storage account, so your VHD's there. You can't, but you can export them to VHD. You can take snapshots of them. So from an architecture level, you have basically the same capabilities, but with managed disks, it's a little bit simpler. It's a less complexity. I did hear yesterday that managed disks are not on the exam yet, but that will be, next time they refresh, it definitely will be. Yes? I don't know about that. So the question is, does standard managed disks charge you for what you provision, not what you use, right? Whereas in unmanaged, you get charges for use. Yeah, and I don't know right now off the top. So let me find out, and I'll get the information to everyone. Okay. All right. So so we're talking about unmanaged disks and managed disks. Again, disks can be resized up to 1 terabyte. If you need a larger than 1 terabyte disk, you can stripe your disks, right? So striping is also a way not just to achieve larger disks, but to get greater IOPS out of those disks. So with striping premium disks, you can achieve 80,000 IOPS if that's what you need, and that's actually going to increase soon. But as of today, you can achieve up to 80,000 IOPS by striping premium disks. You can also encrypt your disks, and there's a lot of different ways you can do this. You can encrypt in the operating system. You can encrypt via Azure. So I have a link here which gives you, I think from an architecture perspective, just realize that your disks can be encrypted at rest. And then then there's also disk caching. So disk caching, I remember seeing that on one of the exams. It's just important to understand we have 3 kinds of caching. No caching, I guess, is a kind of caching. which is for write only and write heavy. So think about your SQL logs where you're constantly writing and not really reading. So the disk caching is optimized for that. Read only is for reading and writing. So the naming is a little poor, I think, but it's, yeah, read only is for reading and writing. And then read write is for operating systems and for applications that know how to take advantage of the disk caching that we do. I think for the exam, just realizing the three kind of workloads, if you think about it this way, none for SQL logs, read-onlys for SQL data files, and read-writes for operating system disks, that will help you if that question comes up on the exam of which to use. So by default, when you get an operating system disk, it's configured for read-write out of the box. Yes? So the comment is, if you've got, which caching should you turn on? The read-write? Okay, so the comment is, if you've got domain controllers, the disk caching should be set to none.
Is that still the recommendation? Because hardware since 2005 hasn't allowed us to turn off caching either.
Yeah, I mean, that is, when I put the content together, so the question is it still recommended to, what is still recommended? To disable the disk caching for domain controllers?
In the olden days, there were hardware where you could actually do that, but not so much in the last.
I don't know, and that sounds like some kind of domain knowledge that probably won't get tested on the exam, you know. So, but that's a good point. All right, so the other thing about choosing a VM are the Azure Compute units. And this is interesting. I don't know if it's on the exam, but it's interesting to know that not all cores in Azure are created equally. And so if you see the table gives you kind of relative performance for our different cores. So an A1 gives you 100. That's just an abstract number. That's 100, right? But a DS1v2 gives you 210, right? So when you're looking at the different, if all you're basing on our cores and everything else, the temp disk, the RAM, the premium storage capability, all those other VM features are not as important. You may also want to look at, well, an A1 is not going to be as powerful as the DS1v2. So just something to realize. And then finally, wrapping up VM disks, there are two concepts in Azure I just want to talk about briefly. One is disk snapshots, and one is creating images of your VM. So a disk snapshot lets you capture a disk at any state in time. You can capture them with managed disks or with unmanaged disks, with standard storage or premium storage, doesn't matter. But you can, when you use standard storage, you are actually taking a backup of the underlying blob that the disk is stored in. And that actually lets you do incremental backups, snapshots as well. With managed disks, you can only take a snapshot of the disk. You can't do incremental yet. And what is nice when you do take a snapshot of your disk, so if I got a 1 terabyte disk and I snapshot it, now I've got another 1 terabyte that I need to pay storage for. But in premium disks, the backups are just put into a standard storage account, right? So you're not paying a premium storage for that 1 terabyte snapshot. So if you take 10 snapshots a day, you can store those in standard storage, which is much cheaper. So the question is, do you have the option to store your snapshots in cool storage? I would assume yes, because the standard storage and cool storage are the same. It's really just the costs involved in the data transactions, right? So it's the same exact API. It's the same thing, except that when I retrieve data from standard storage, those transaction costs are higher for cold storage, because the intention is I'm not going to be touching that as often. So I would tentatively say yes, but I don't know for sure. All right, so that's snapshots. And then the other thing to realize are images. So if I create a VM and I've got it kind of configured for how I want, when I want to deploy all my customers, I want to give them the same exact configuration, and my VM's got multiple data disks because it's a database. I can take an image of that VM and I can then create new instances of that VM via that image. So the distinction here between a snapshot, I could do kind of the same thing with a snapshot, but a snapshot only works at the disk level, whereas the image works at the entire VM level, including data disks. So if I take an image and I create a new instance of it, I'll get not just the VM, but I'll also get the data disks as well. So VM scaling, so when you create a VM in Azure, you may want to, you have your workload on your first day, but you may need to increase the size to handle the traffic, or you may want to decrease the size of your footprint to save money. There are two kind of concepts for how we scale in Azure. One is we scale up or down, or scale in or out. Scaling up or down is basically just resizing your VM, right? There's something to understand here. When you do a resize, there's some things you have to take into account. If you have deployed your VM in a cluster, right, and you really get to choose this, when you create a VM, it gets put into a cluster, right? If you want to resize that VM to another VM size that's supported by the cluster, when you do the resize, all that happens is your VM gets rebooted and it comes back up as that new size. Because it says, oh, I'm in a cluster where I want to go from an A1 to an A2. I can do that because this cluster supports A2, right? Now, if you want to go from an A1 to a G1, right, the cluster that you're in, if you were, especially if it's an older cluster, it may not be available. So when you go to resize, you may not see that option, right? You may not see the option for a size that you need. So in that case, you need to shut down your VM via the portal or command line, deallocate it, and then choose your size. And then your VM will get moved to a cluster that supports that new size. So that takes a little bit more time than just doing a simple reboot. Either way, it's an offline operation if you want to do a resize. That's important to realize. And if your VM is an availability set, and we'll talk a little bit more about availability sets in a second, and you resize it and it requires being moved to a new cluster, all the VMs in your availability set will need to be moved as well, just because of the way the backend works. So, so that's resizing. And then there's scale in or scale out. So if I have one VM and I want to create 10 VMs to handle the load, and then go back down to 5, I can scale in or out. We have a tool called VM scale sets, which makes it easy for you to do that. You can also write Azure automation. You can do all of this with any of the tools you want or with any other external tools via the APIs. But internally, we give you VM scale sets. We give you Azure automation. You can also do this on a schedule, or you can auto scale. So if you know that you're busy between 9 and 5 p.m., you could say at 9 o'clock, I want 100 servers, and at 5 p.m., I want to go back down to 10. You could build that into your VM deployment solution. And then there's also auto scale. So you could say, hey, when the average CPU on my machines goes over 80%, I want you to bring up another VM, and once it drops down to 50% for 20 minutes, drop off VMs. You could build all that, and you can build that off of kind of built-in VM metrics like CPU and RAM. But you could also build your own custom metrics, right? So you can go deeper into the OS and look at metrics that get exposed via, let's say, the .NET framework, right? But you could also, using a tool like Application Insights, which is our kind of internal telemetry tool that you can kind of build into your applications, you can really use any custom field. So if you're tracking the number of users on the system and you want to scale that way, you can do that too. So you have a full range of ways you can auto scale your VM deployments.
Hey, Mike, quick question. So Azure automation, you have it in red there.
Yes.
But it's not really part of any of the agenda. So is the point there just, from a test perspective, to have an awareness, or?
Yeah. So the question is, I have Azure automation in red, and is it really? It has nothing to do too much with VMs, but is it there for awareness? Yeah, it's there for awareness on a way that you can scale your VMs. Okay. All right, and then we're going to talk later about ARM templates, but just when I was putting this together, I was looking at the VMs and the ARM templates, and there are some things I wanted to point out, which I think are important to understand also when you do VM deployments, which is your VM name doesn't have to necessarily be your computer's name, right? So the VM name is the name that the Azure platform sees, my VM1, VM2, VM3, but the computer name could be the same thing, or it could be something different. It could be, you know, that'll be the host name of the machine that the DNS uses and other machines see. So just realize they don't have to be the same thing. When you're deploying, right, a marketplace image, the important things to realize are the publisher, the offer, the SKU. So, you know, if I want to deploy Canonical's Ubuntu, I have Canonical's publisher, Ubuntu is the offering, the SKU is version 16 point whatever, and the version could be, you know, the semantic versioning beyond that, right? There's something called latest. So if you just put in latest, you'll get the most recent version of that SKU that's available. And then the other important thing are custom script extensions, right? So when you deploy a VM into Azure, you can also attach a script extension which will do some kind of initial configuration for you. So I deploy my VM, I say, if it's a Windows VM, I have a PowerShell script that says, here, go install IIS, go do this, you know, make the changes in the firewall, you know, add these users, whatever you want to do. Same thing, if I'm on Linux, I can have a bash shell. And so that's nice. So when I bring up a VM in Azure, I'm not just getting some kind of, if it's not my own custom image, I don't have to just get a raw, you know, brand new operating system. I could do some configuration on it automatically. And really, you can do anything you want. So you can have your application. You could build a mutable infrastructure architecture where you bring up the VM and the PowerShell goes, grabs the latest code, installs it, and you're up and running, and you don't have to touch the VM at all. So these are some just high-level VM recommendations that I think are good for the test and in Azure architecture in general. These are our recommendations. Use premium storage for production. Use managed disks over unmanaged disks. That makes life easier. When you do scale in and out, make sure the VMs are in an availability set, and we'll be talking about that next. And then it's also important to know that if you stop a VM from inside the operating system, if I'm RDP'd into a Windows machine and I say shut down, that shutdown is, while the VM is shut down, and Azure will say the VM is stopped, it is not deallocated, and so you will still be charged for that VM running. So if you need to shut down VMs, you have to shut them down via Azure. So that's the portal, the CLI, whatever, not from the VM, right? Yes? The question is, does it release the IP address if you shut down from inside the operating system? And the answer is, I don't know.
Yeah, that's a caveat. So
Yeah.
when you deallocate the VM, it releases your private IP.
Oh, interesting.
So to make sure that you retain its private IP, set it as static. So you get that same IP all the time.
So then the comment is, if you do shut down the VM from inside the operating system? Yes, yeah, right. So the comment is when you deallocate via the portal, you lose your private IP address. So if you need to keep it, you should create a static IP address, yes. All right, so the next section is availability sets. So we have all these VMs. Oh, question. Yes.
So if I understand that way, so that means if I were to spin up the VM to a standard disk, and if I require, let's say, 16 terabytes of storage, I would now 16 HDX, route, extract it across 16 disks. So for standard disk, it would not be it would be no SRA. So in this case, if I were co-hosted with a noisy neighbor, it can potentially not have server in terms of performance, or is that how I'm understanding it?
Yeah, so the question is, if I need 16 terabytes and I stripe 16 terabyte disks of standard storage, because there's no SLA, will I be affected by noisy neighbors? I would say that we don't. I'm not sure if it's a noisy neighbor or the platform itself, but there's just there's no guarantee that you'll get a minimum number of throughput for that, right? So there's what we publish, right? I think there's 500 IOPS per standard storage disk, so you could stripe those and get the IOPS on top of that, but there's no SLA for that, right? Just like when we do our replication from our geo-replicated storage from one data center to another region, there's no SLA on how long that will take, right? So you can move a few, megabyte files in a few seconds, or it'll take a few terabyte files minutes, right? There's no SLA. So yeah, with our standard storage, there aren't SLAs, but with premium, there are. All right, availability sets. So availability sets are, does everyone here know what availability sets are? Okay. All right, so let's get into it. These are important, super important for the exam. So let's just take some time to understand how these works. Availability sets make sure that your application, a load balance application, can be highly available in Azure, right? And we do that with two concepts. One's a fault domain and an update domain, right? So a fault domain, think of a fault domain as I've got an Azure data center, right? You can think of it for now as just one building, although Azure Data Center has many buildings. But think about one building with multiple racks, right? Racks of servers, racks of servers, racks of servers. So I have a server here, and I have a server here. Each server has its own power connection and network connectivity connection, right? And so when I put VMs into an availability set, it will start to put my VMs into separate fault domains, separate racks. So the first VM goes into rack 1, the second VM goes into rack 2, the third VM back into rack 1. If I have two fault domains, if I have a third fault domain, I would stripe across 3 of them, right? And this is important because what happens if the power goes out for one of these fault domains, right? That the rack loses power or network connectivity, then the VMs in that fault domain will go away, right? They'll go down, right? And I don't want my whole solution to go down, so that's why I want to make sure that I put a certain number of my VMs across separate fault domains, so that just in case something happens in the Azure Data Center, I'm going to minimize the chance that my entire application goes down, right? So in Azure, you can have most of our regions support 2 fault domains. Some support 3. And so if you're building one, if there's a third available, you can create the availability set with 3 fault domains, right? So you don't have to worry about putting each VM into its own fault domain by itself. That's what Azure does for you. And you just have to say, I'm creating an availability set. All my VMs are going to go into this availability set. So if I have, if I have two fault domains and I have 10 VMs, 5 will end up in one fault domain and 5 will end up in another fault domain. And if something happens, if there is an outage, right, you've minimized. Now, if the entire region goes out, obviously, if there's a meteor hits that region, right, well then high availability within the region doesn't matter anymore. The whole region is out. And if you need to provide even more availability than that, then that's where you would have your solution deployed to multiple regions, right? And use something like Traffic Manager to load balance between them, or use active passive, right? We're going to talk about regional availability later. But within the data center, within a region, I use availability sets for making sure that I could be as highly available as possible. So that's fault domains. There's another concept called update domains. And what update domains is that occasionally, very rarely, but probably more frequent than actual outages, we may need to do maintenance on the host VMs that your VM, on the host machines that your VM is hosted on. And so what we'll do is we can put those into separate update domains. And you can have up to 20 update domains in any of our regions. And what that means is I will be so those in that same scenario where I have 10 VMs and I have 5 update domains, 2 VMs will be, each update domain will have 2 VMs. So that means if the platform does need to do an update, I'm not going to take down all of your VMs. I'll only take down 2 at a time. I'll only take down 1 update domain at a time, right? And that way, your load balance application, so I have 10 VMs. Maybe occasionally 2 of them may go down or may get rebooted because of some Azure maintenance, and that way the application isn't that affected, right? If you don't use the danger of not using availability sets is you have no control over where your VMs get hosted in an Azure data center. So while it may not be likely, your VMs could all get put into the same rack, right? And if the rack loses power, your whole application goes down, right? So it's really just a simple step, when you're creating your VMs and you're doing scaling in, scaling out, or you're saying, I need 4 VMs to support my application load balanced, putting them in availability set, there's no charge for it. It's just a hint to the Azure platform to say, hey, these VMs are all kind of the same, and we want to put them in separate places so that they all don't go down at once. All right, and the other guidance for using availability sets is that each role should be in their own availability set as well, right? So your front-end web tier should be in an availability set, and your back-end SQL database, let's say, should be in an availability set. So that's the guidance for that too. So the question is, why would I use availability sets as opposed to live migration? Yes. The comment is, if there's live migrations happening in the back end, why do we have to worry about availability sets, right? Well, you still want to worry about the fault domains, right? The update domains, there has been less concern about that, I would say, since we've implemented live migrations, right? We used to have to take down the reboot VMs a lot more often, right? So in some ways, availability sets come out of that where our VMs would go down more often. But now, in the past few years, where we do have these live migrations, it's less of a concern. But there is still occasionally times when the VM will get rebooted for some planned maintenance or something. And so it does happen less frequently, right? But then I can't see the reason why you wouldn't do this anyway, right? I mean, so it's good insurance that's free. Yes. Yes.
Can I assume that the 3 copies of my storage, the other 3 copies, are also pretty different?
That's a good question. So the question is, I understand fault domains and availability sets for VMs, but what about the underlying storage? Because if the storage is not in an availability set, it doesn't matter if the VMs are. If a storage cluster goes down and all my VMs are in there, all the disks for my VMs in there, I'm still hosed, right? So the guidance is for that is that you should put all of your disks that are going to be part of a solution, like an availability set, in separate storage accounts. So I create a new storage account, and I put my VM disk for VM1 in that storage account. I create another storage account for VM2, right? And so the VMs are all in the same availability set, but the disks that underlie them are in different storage accounts. Now with managed disks, we take care of that for you. So if you create a managed disk for a VM that's in an availability set, right? So when I create the VM, I say whether it's part of an availability set. I also say if I want a managed disk. The platform is smart enough to know, and it puts it in separate storage accounts and actually does even more. Because even when you create separate storage accounts, there's still no guarantee that those separate storage accounts are going to be in different racks and different stamps. that's the best that you could do yourself to maybe ensure, that's the best that you can do, right? But there's still no guarantee. With managed disks now, you have availability. What? A stamp is when we deploy resources to an Azure region, it's basically a stamp. It's like a container that has a set of compute and racks on it, and they're kind of these hermetically sealed stamps, and it's really interesting. Like when 20% or something of all the resources in a stamp fails, they take the whole stamp offline and they replace it, right? It's just, it just turns out that doing maintenance on individual servers and everything is more expensive than just chucking something that's, on its way to dying and bringing something in. So that's, yeah. So So the comment is there's a script on TechNet that will let you move your storage account to a different stamp. I didn't know that. So will it let you say what stamp, or is it just? Oh. Cool. Awesome. All right. We're running out of time here, so let's talk about ARM templates. So we talked about VMs. We talked about how to build VMs and availability sets for high availability of those VMs. Now ARM templates is the other section I want to talk about. So an ARM template is a JSON file that represents your resources in Azure, including VMs, right? And with these ARM templates, you can deploy an entire solution to Azure, and then you could also remove that entire deployment. So you can spin up your entire Azure infrastructure when you get in the morning, and then you can tear it all down at night if you want, right? And the ARM template is a kind of declarative way to do that. Because you could do all that with CLI scripting and PowerShell scripting, but the ARM template is a really nice declarative way to do it. So it's important to know for the exam just the capabilities of these ARM templates and why you would use them and how you use them. So let's get into it. And before I talk about ARM templates, let's talk about ARM. ARM is Azure Resource Manager. And the way you think about it is that every service in Azure, whether it's a VM or a database or an IP address or a network card, all of these things are resources, right? And with ARM, you can control your resources. You can control permissions, who can do what with resources. And resources all belong to a resource group. So I have a group called, production, VMs, right? And everything in production VMs, all the resources in production VMs belong to that resource group, and resources can only belong to one resource group. So the resource group is another way I can control access to VMs. And when I create these ARM templates, when I have my whole declarative solution in JSON, I deploy that whole thing into one resource group. All the resources that I create will belong to that group. So we'll talk about the structure of these ARM templates and some of the things you can do in the ARM templates. So this, at a high level, is the structure, right? There are parameters, variables, resources, and outputs. I just want to talk about each one really quickly. So parameters are values you could pass in. So when I'm deploying this ARM template, I want to pass in, the names of my VMs, usernames, the passwords. I want to pass in anything. I want to pass in the size of the VMs I'm going to create, the number of VMs I'm going to create. All this could be parameters that get passed in. So when I deploy via the CLI, I deploy via the portal, I'll have some kind of form or some kind of way to pass in these parameters, and I'll show that to you. So parameters are important for reusability, right? And that's going to be on the exam, which is, we're going to author an ARM template, and you want it to be reusable. You want to be able to let your developers create a new environment, or you have a new customer you sign up, you want to create a new environment for them. But you want to be able to make sure that the usernames, passwords are different, or a smaller customer gets a smaller size VM, larger customer gets many more VMs than other customers, right? So parameters let you, customize a generic template. And it's important because the test, some feedback I heard is the test asks you, how can we make these templates reusable, right? And if I change this or that, will the template still be reusable? So you got to think about what, when we're looking at these templates, right? If I hard code in the name of a disk or the name of a VM or the name of a storage account, now I may not be reusable, right? The VM may not be reusable. So when you're looking at these when you're looking at these ARM templates, you want to make sure that you've parameterized the right fields so that the templates are reusable. So that's parameters. There's also variables, and variables are just a way to store names that you build inside of the ARM template that you're going to reference again and again. So if I create a virtual network, right, and I use it by concatenating the name of my resource group and the name of the application and the name of the region, whatever, right, I have that. Now I want to use that multiple times because I want to add network cards to that virtual machine, and I want to add subnets, and I want to add network security groups. I can store that as a variable that I can use later on in the template. And then the last item are resources, right? So not the last item, sorry. Second to the last item is our resources. And so these are the actual things that we're going to deploy into our resource group. These are the actual resources we're going to create, right? This is the VM or the SQL database, any of those. So there are some standard properties that you would set, but every resource has its own set of properties, right? And you don't have to understand or know each one, I would say, from an architecture perspective. Just be aware that this is where resources get deployed. So these are the kind of standard elements that are part of a resource item in the ARM template. And then the last one are outputs. So outputs are useful because if your ARM template generates things for you, if you're using like a function in the ARM template that generates a random name, or if you are going to provision an IP address, you want to know the IP address, outputs will return, whatever tool is you're using to deploy this ARM template, the output will return to that tool, whatever you pass back as an output, right? And so when you create these resources, obviously you can go into the portal or use CLI and see all the resources that were created. But if you're going to use some kind of automation and you want to say, hey, I'm going to write this tool that's going to go to deploy this ARM template, I want to get the IP address back so I can go update some other tool with that, that's where outputs will help you, right? Because some things aren't, we can't know what the name will be or what the IP address will be ahead of time, so we can use outputs to learn. ARM templates also support functions. So this is a whole, almost like programming language inside of ARM templates, right? So I can do all these kind of string manipulation things like concat, and I could also do Booleans like first, last. So I can build all this kind of complex logic in here, and I can also get access to the resource group, the resource ID. I could use that that contextual information to populate the names and values that I use inside of the ARM template. So just be aware that function exists, right? So you don't have to populate these values externally. You can use the ARM template to help you do that. ARM templates can also be nested, right? So this is important to realize that your ARM templates can be generic, and then you could even build them modularly. So you could have an ARM template, all it does is deploy VMs. Another ARM template, all it does is deploy SQL databases, right? And that way, you can use an ARM template, you can use a generic template that calls subtemplates, and you can really build a complex set of these templates that all kind of meet your standards and whatever requirements you have, right? But aren't tightly coupled to each other. So that's a nice capability. And then the resources inside the templates have dependencies, right? So if I create a VM, before I create the VM, I might want my network card, right? Because I want to attach the network card, right? So, and before I attach the network card, maybe I want a virtual network, because the network card, when it gets created, we want to attach it to the virtual network. So you can create these list of dependencies so that the resources get created at the right time. And ARM template, another nice benefit of ARM templates over using scripting is that all of these resources will get deployed in parallel when possible. So if I create 100 VMs, I could create, the ARM template will deploy those 100 VMs in parallel if it's possible. I can control that in the ARM template if I want it to be serial, but by default, if it can deploy resources in parallel, it will. Yes?
What is the percentage of questions that you're supposed to might get an exam depending on templates, dependencies, parameters?
The question is, what percentage of questions on the exams will have to do with ARM templates? The feedback I got from the guy who was just here, Michael, who prepped us when we were writing the content, was that there were a bunch of questions on the most recent exam about ARM templates. So just understanding a high level how they're designed, I think will be helpful. So yeah, I know it's a lot to, there's a lot of detail here, but if you just take the red text and you just kind of understand.
I was just looking at some of the questions. They were saying, what is the parameter, or what is the thing that you use for deploying a new VM?
All right.
And then they have these code, like four different options.
All right.
So just wanted like how the questions like.
Yeah, yeah. It's really essential part of the platform now, so I think they want you to know about it. All right, so a couple more items on ARM templates. You can use ARM templates to create multiple instances. So like again, if I want to create 100 VMs that are all kind of the same role, I just want to load balance across those 100 VMs. I don't have to have 100 different VM resources, right? I can create loops and just say, you know, create 100 VMs, and I can use the copy index function that just returns the iteration I am in the loop, so I can attach that to the VM. So I have VM1, VM2, VM3, VM100, right? So that's another thing you can do with these ARM templates. And then, of course, those will all get created in parallel for you. So just to wrap up, ARM templates with some advanced topics. You can check out these links. I'm not going to get into them right now. So how do we deploy these templates? There are a few ways you can deploy them via the portal. So you can just do a template deployment, copy and paste your template in there, and deploy them. You'll get prompted for all the parameters in that template. You could also use our Quickstart sample. So we have a few hundred sample templates for many different types of scenarios, building VMs, building VNets, you know, deploying popular open source technologies on Azure in an optimized way. You can get those from GitHub, or you can get them right from the portal. You can go into the portal and you can search for those templates and deploy them right from the portal. Or you can upload templates, the JSON files, into your Azure subscription and store them there and then deploy directly from the Azure portal. There are some labs. These are more like exercises. I have actual labs at the end that I think are better than just going through these exercises. But Dan included these in my deck here. These are just some exercises for working with resource groups and Resource Manager. You can deploy the templates with PowerShell. I'm not going to get into the details of the syntax here. But one thing I do want to mention in red here that's important to understand is that templates are idempotents, right? Or they are upserts, right? If I have a template that has 10 VMs in it, and I add an 11th one, when I redeploy that I can redeploy that template. It's not going to recreate all of the initial 10. It's going to see, oh, I already have these 10 in my resource group. I'm just going to deploy the delta, which is that one that is that extra one, right? Now I could also pass in a mode, incremental or complete. So incremental is the default, right? And so That incremental is, if I see any changes, I'm going to leave all of the resources in this resource group alone, but if I see any changes, any additions, I will add those additions, right? A complete one will say, the ARM template owns the resource group. So if there are some resources deployed in that resource group that are not in the ARM template, I'm going to delete those. So if I have some old VMs or something in that resource group, and now I deploy to that resource group a brand new ARM template that doesn't reference those old VMs, those old VMs will get depleted. I'm going to, if I use complete, I'm going to say this resource group is going to look like this ARM template. So those are two things to be aware of when you deploy ARM templates, whether you want to do an incremental deployment or complete.
Additions, literally just resource additions or property additions and property changes?
So the question is, are additions just resource additions or additions to properties or changes on properties of existing resources? My understanding that it's changes for the properties as well. So if you change your VM size, it's not going to ignore that because it found that VM. It will actually change the VM size as part of that. Yes.
So do you recommend any tools that we can use to compose our own JSON template?
The question is, are there any tools that I recommend for designing ARM templates? Visual Studio has some good editor for it. There's now Visual Studio Code has some good autocomplete for JSON. I would start with one of those hundreds of Quickstart templates that kind of matches what you want to do. And you can start from there and modify it. And then the last thing is when you go into Azure and you go to any resource group, you can export the resource group. And it's nice because you can export the resource group. It will try to parameterize it for you. And it will give you all the code you need for PowerShell, .NET, Ruby, Python for deploying that ARM template. So there are some tools. Here's some more resources. You can look at those later. You can deploy with the CLI. I won't get into all of the details for that. All right, so just to wrap up the whole talk here with talking about availability, we talked briefly about high availability with availability sets. We also have the concept of regional availability. So I have my VM deployment. I have them highly available in my East US. Everything is good. But what happens if my SLA with my customer is that even if East US gets a meteor shower and gets destroyed, I still need my app up and running. That's where you want regional availability, right? And the important thing to understand, this is about regional availability, is that in the event of a really broad outage, right, where the East US goes down, or the whole US goes down, right, something happens, Azure will prioritize one region pair over the other. So the East US is paired with the West US, right? So when you use storage and storage does the geo-replication, it goes to the West US. So if East US and West US both go down, only one of those will be prioritized to come up first, right? So when you do regional availability, outside other constraints, you want to be able to put your application in those pairs, right? Because if both go down, we're going to prioritize bringing one up. And now if you're in the East US and you're also in North Central US, right? If those both go down, if the whole US goes down, right? We're going to only prioritize, we may prioritize the other set of pairs, not yours. And so your time to come back might be longer. Yes?
Will the specific regional pairs be on the test?
The question is, will the specific regional pairs be on the test? I don't think so. I'm pretty sure they won't be. I mean, but just the idea of what a regional pair is. So there's something on our website on the Azure documentation called the Azure Architecture Center. And the Azure Architecture Center is great. I lifted all this content from there. And it gives you architectural guidance for developing different types of, architecture patterns, like a regional availability pattern in Azure, right? So it will tell you the guidance. It'll give you the pluses and minuses, the things you have to think about. So rather than trying to just going through all the stuff I lifted from them, I would just point you in that direction. The details are in my slide, but I have the link here to the real reference architecture behind this. So just things to think about. That Azure Architecture Center is actually really good for not just regional availability, but lots of different architectures in Azure. And if you're going to take the exam, I think it's good, and it's written in a more engaging way, let's say, than the other documentation. Yeah. Yes. So in active passes is what we're recommending in this design. And what you would do there is you put a traffic manager in front of your application, and you would use priority routing, right? So the priority would say, only go to this region, right? And if that region is unavailable, I'll go to this region, right? And because I'm using traffic manager, I don't have to really update my DNS or anything like that. Active is where I could load balance between both of those regions, right? And there I can use another one of the routing options. I could use something like performance, where my users on the West Coast can use the West US, and my users in the East Coast can use the East US, and traffic manager takes care of that for you. Well, yeah, the database here, the example is with Cassandra, right? And it's doing its own kind of replication. That would be how you do database replication across both and an active, right? That is going to be outside the scope of the architecture. But we can talk about that if you want. All right. All right, it's been an hour, so I have time? Okay, cool. All right. So just to cap off high availability, there's a distinction between when we say high availability in Azure, we mean in the same region, right? You want your application to be highly available. If you hear that, if you see that in an exam, that should mean in the same region. Regional availability means across regions, right? So you'll always hear, or you'll hear disaster recovery, right? That's also like an active passive architecture for regional availability. So just realize those terms. Then there are these other patterns. I don't think those are going to come up in the exam because they're more about your application than Azure architecture. But just concepts to be aware of. So they asked me to talk briefly about containers, but there's going to be a session about containers later. So I'll just say we like containers in Azure. We have Azure Container Service, which is still an IaaS-based service. It creates VMs for you, but what it does is it creates an optimized Docker cluster for you. So rather than you building your VMs, installing Docker, choosing and installing and configuring an orchestration service, we do all that for you. So in 20 minutes, you're up and running with your 8-node, whatever, Kubernetes Docker cluster. So we'll hear more about that later. All right, so a few more minutes. Let's go through some of these sample questions. Or was there any more questions about any of the content, or do you want to do these fun questions? Yes? All right. All right, so the question is, can I deploy anything in an ARM template? Because we have a lot of PowerShell, and it's kind of annoying to maintain that, I imagine, right? And ARM template better. I want to say yes. There are probably some things that, like identities and like Azure Active Directory stuff, there might be some things that are still legacy holdovers from Azure Service Manager what? So for keys and key vaults, I know you can create the infrastructure. I don't know if you can actually deploy keys to them, so I don't know if you can create content as part of the ARM template for any of these services. Like a SQL database, I can create a database. I can't create tables and records in them, so maybe that is a good way to think about it. All right. All right, so what's the answer for this question? Yes, 4. That was easy. All right, I have an application requires consistent and guaranteed amount of IOPS and throughput for accessing data disks. What is the most cost-effective option? Yes, Azure Premium Storage Disks. All right, my VM needs an F drive with at least 2 terabytes of space. Which of the following do I need to consider when designing my VM? What? Yes, all 4 of them. You can use all 4 of these for that simple requirement. All right, I need to create a VM with 1 data disk. I must be able to export the disk to a VHD file and host in a storage account. I need to take a snapshot of the disk. Which of the following can I use? No, all of them as well, right? Because even your managed disks can get exported to a VHD file if you need it. I've created a VM with database, 2 data disks. I want to be able to deploy this again. What's the simplest way to redeploy this multiple times? Simplest way. Yes, capture an image, right? Snapshot, remember, is just of the disks, so I wouldn't get my 2 data disks. And an ARM template is more complicated than we need, and a VHD file is not going to help us here. Every VM and availability set gets one fault domain and 1 update domain. So if I could just so that everyone really gets this, because if there's one thing you leave with, you have to understand this. So if I have fault domain 1 and fault domain 2 and update domain 1 and update domain 2, a VM, my first VM that goes into this is my availability set up here. The first VM that goes in here will go into fault domain 1 and update domain 1. VM 2 goes into fault domain 2 and update domain 2. VM 3 goes back into fault domain 1 and back into update domain 1, right? And so on and so on. So every VM gets 1 fault domain and 1 update domain. To build a highly available VM solution, I need at least 2 VMs in the same availability set. Yeah, so just important for the exam. To deploy an externally available Azure ARM template but keep it secure, I can, this is something we really didn't get into, so I'll just show you the answer, which is a storage container. Because if I want to deploy a VM, an ARM template, or a sub template via nested templates, those need to be externally available. Like the tool that deploys the ARM templates needs to be able to reach that ARM template JSON file externally, like via public internet, facing address. So if I host it in a public Azure storage container, it's not secure. If it's on my on-premises corp network, the tool is not going to have access to it. And if I host it in a private GitHub, it's not going to have access. So Azure storage container with a SAS token is yes. Or Azure File, you can access it, Azure File Storage too via SAS token. My ARM template needs to manipulate strings to name and reference the resources correctly. The easiest way to do this is for, yes, right? I don't have to, I could do that all inside the ARM template with the functions. And my solution needs to always be available, even if an entire Azure region suffers an outage. What is my best option from among the following? This is kind of wordy, so I'll just get into it. So it's number 3. I could deploy a primary solution to an Azure region nearest my customer and a secondary solution in the primary's paired Azure region, because that way I have the best chance of my application coming back up. And then this is the link to the labs, but it's in Dan's GitHub, Dan. And that's it. So now you know everything about ARM templates and VMs.